Good morning, my name is Juan Carlos Amocampo, and today we're going to be analyzing the problem situation of how an airbag works with the point of view of the chemistry. So first we need to consider these three reactions. In these three reactions, we're going to be having initially in the airbag sodium acide, potassium nitrate, and silicon dioxide. So what will be happening here is that when a crash hits, the sodium acide will start to generate big amounts of nitrogen, but as well of a solid. So then it will need to be nullified by the second reaction, but the second reaction will generate a toxic gas. So the third reaction, what does is to eliminate this gas. It will be really hard to work with these three equations, so we can have a general equation. In order to do this, we need to multiply the first row by 5 and change the product of the third reaction. So this will be how it ends. This is because it will be easier to eliminate the sodium, and the values of the product of the third reaction are available in order to research them. So this will be the final general equation. Now, in order to find the reagent, we need to use the ideal gas law. So we know the amount of moles of nitrogen that are needed to inflate the passenger and the pilot airbag. We need also to consider that when we solve for N, the volume will be changing. For the pilot, we're going to be using a 67 liters volume, and for the co-pilot, we're going to be using a 146 liters volume. So now that we have the value of N, that in the case of the pilot, it's of 2.73 moles, and in the case of the passenger is 6.1, we can make a rule of 3 in order to gain the grams of nitrogen needed. In the case of the pilot, we're going to be using 113 grams, and in the case of the passenger, we're going to be needing 253 grams. Both grams we're talking about of sodium acide. So now, if we see here, in order to calculate the values of enthalpy, entropy, and Gibbs of the general equation, we need the values of each component, and we're going to be subtracting the sum of the products with the sum of the reactants. But we need to remember that in this case, the values are going to be changing because we are only using 2.6 moles of nitrogen, or in terms of sodium acide, 0.17, and in terms, or 6,